When iron ore is purified, it is heated at very high temperatures with the carbon reacts with the oxygen in the iron oxide, forms CO2, and CO2 is a gas that comes off the hot ore refiner, and pure iron is remaining in the smelter. We're going to balance this chemical reaction. This could be a very profitable chemical reaction. How many grams or tons of iron ore do you need to mine, and how many grams or tons of carbon do you need to add to heat up, and how much of this can you sell? We're going to do an accordion of each of our reactants and products to help us balance this. Fe2O3 iron oxide. That is our accordion, as if we stretched out to remove the baby numbers. We need our ledger. Iron, oxygen, carbon. 2, 1, 3, 2, 1, 1. Okay, carbon's already balanced. Don't mess with that. Oxygen, let's balance out the iron. So my only trick I have is to add a Xerox or identical copy. My irons are balanced. Let's balance out our oxygens. I need more oxygens on this side. And I have to add this whole thing, because CO2 is what degasses off the smelter. Not one oxygen, CO2 degasses. That changes things. We now have 4 oxygens, 2 carbons. Focusing on the oxygens, we need 1 more oxygen over here. And again, the only trick in our book is to add an identical copy. Sometimes students find it helpful if they do this. Like that circle designates this accordion as like a molecular packet of the ionic compound. And here's the second packet. You have to make a copy of whatever is inside of there, not a part of it, but the whole thing. We have 4 carbons, 4 irons, 6 oxygens, 1 carbon. Oxygens, let's go back over here and balance out the oxygens one last time. Oxygens are balanced, 2, 4, 6, 3 carbons. Let's pop back up here to irons. This is an easy fix. We can do this because we're talking about iron atoms, solid metal. Irons are balanced, oxygens are balanced, carbons are balanced. Now they're balanced. The ledger is proof that conservation of mass. 4 iron atoms went in, 4 iron atoms are going to come out, 6 oxygens in and out, 3 carbons in and out. In the balanced chemical reaction, it is a 2 to 3 ratio of reactants and a 4 to 3 ratio of products. These numbers cannot be reduced down. So that is our final answer. Now let's do a limiting reactant problem with this balanced chemical reaction. We're going to solve the limiting reactant problem using the graphical method first, kind of visualize these atoms reacting, and then we'll solve it using a scaffold method. Graphical method is using pictures. In our smelting pot before, and this is our smelting pot after. Let's say we have 3 tons of iron oxide. And I've tried to circle the iron oxides to kind of show that. I put in FeO3 in an accordion style. These are not structurally representative cartoons. These are literally just to keep track of the irons and oxygens that are present. And we have 4 tons or 4 equivalents of carbon. Now, over here, we're going to iron and CO2 is what's produced in the after. So let's start producing iron and CO2 until we have exhausted everything in here and see how many irons and CO2s can be produced total. So we have 1, 2, 3, 4, 5, 6. We have 6 irons that could be produced total. And we have 4 carbon atoms and 9 oxygen atoms. Let's just start doing this one at a time. We got an iron there, and then a CO2. So that uses up an iron and a CO2. Make another iron and a CO2. Let's make another, whoops, there's our other CO2. One more iron and CO2. And then another iron and CO2. I could potentially make another iron, but I can't make any more CO2s. I could make maybe one more iron. But I have an excess of oxygens left here, okay? So the maximum number of CO2s that could be produced is 4. And the maximum number of irons that could be produced is 6.